Okay, picking up where we left off, we're in the middle of talking about the rules for how to do scripting. These are philosophical rules; they're not technical rules. Use an if statement here. That's not what this set of rules are all about. So the next one on the list is have a naming convention that you stick to. So, if, for example, if you have, I don't know, in this case, score. So I want you to enter in a numeric score. So I probably should have a variable and a naming convention that kind of makes sense. Things like letter grade and score kind of sort of make sense. Do you see how in line 9 I use, it's called camel case, where the name, the variable, starts with lowercase, and if there's two words that are put together to make a variable like letter grade, I don't want to have a space in there. That's pretty bad. But if I bump them together, the second one has the uppercase, so it's a little easier to read. Obviously, the machine doesn't care. This is about you, right? So that's why it's called camel case, because there's a hump in the middle. Cool. All right. So some sort of a naming convention, and make sure your variables make sense. Don't ever use like X. No, it's a score. So let's call it a score. And no, it's not Y. It's letter grade. So that when you're reading, remember the goal. One of the goals of this is make this thing readable. So if you're going to try to make this thing readable, then for God's sake, let's use variable names that actually make sense. Okay, good. Use a style guide. You can find one of these online that talks about, indentation and all sorts of other things you can do. Start with a comment block. So yes, I actually have some sort of a comment at the block because, again, let's say I run across a script and I'm not even sure from the name. I mean, what do we call this guy? If I call this guy, I don't know, score to letter, okay, that to me makes a little bit of sense. But if you don't know that I'm a teacher and you're saying score to letter, what the hell is that? Well, then you might want to look inside, and a comment like on line 2 would say, this program takes a numeric score and turns it into a letter grade. And then you go, oh, okay, I got it, right? So that line 2 is kind of sort of important. Most people would put in more to it. They would, put in like your name, written by, maybe the date or something in there to indicate, who did it. And because if I have a question, I might say, hey, Bob, I understand you wrote this script last year. Or what the hell does it do? Okay. And they're kind of sort of suggesting that one of the rules is you don't make scripts set user ID. Okay, that's just bad form. Obviously, sometimes you might have to. Remember, for example, in the thing I was talking about, if I was to create a one-line script that did the mount command, okay? If I did that, I would not have the first word in the script sudo, okay? I wouldn't do that. I would have the regular mount command, and then let's say I called it mount temp, okay? That's the name of this guy. And then I would say sudo mount temp at the command line. You see the difference? That way, I don't have to make that guy set user ID, okay? Because I'm running the sudo command on that. Cool. All right. Remember, sudo is a hell of a lot better than set user ID because when using sudo, I can kind of keep track and cache up the credentials if it's been less than 5 minutes and all that kind of stuff. But set user ID, there's no caching, there's no recording. I can't really tell who's doing it. If somebody did it 15 times, I would never know. That kind of stuff. Okay, cool. And then on page 188, they talk about the 5 golden rules for error messages. Okay, so if you have an error message, one of the things you probably ought to do is instead of displaying that to the window, the normal standard out, perhaps you ought to use like the echo command and send it to standard error. Now, by default, standard error and standard out are both going to point to the same screen, right? Okay, so that would be kind of cool. Include the name of the program in the error message. Because, for example, if I'm, remember how, if I had like a long listings going on and I redirected the standard out, but left the standard error going, this thing will pop up and say, illegal operation on line 42. But I've got 5 of these things running. So which one spit out the error message? So wouldn't it be kind of cool if it said, number to letter, illegal. In other words, put the name of the script in the error message. Okay, good. Because otherwise you might say, well, thank you for your error, but who the hell's having the problem? I'm running 5 scripts right now, and so one of those 5 has a problem, but I can't tell which one. And then, in a typical way you would do an error message, you don't just tell them what's wrong. Okay, that's obviously one of the things you should do. You couldn't, obviously you don't want an error message that says, error, this program is about to crash. Like, oh, that's not very helpful. So you should probably include what went wrong, if you can figure out what went wrong. And then perhaps, not always, but perhaps you should have like a detailed error message that says, this parameter, I was expecting this parameter to be a number, and it turned out that this was not a number. That kind of stuff, be a little bit more detailed. And then lastly, have an exit code that's not equal to 0, because one of the things you can do later on, we're gonna have like run 2 scripts back to back, and one of the things that the machine does is it can detect whether the first one failed. It won't run the second one, but if the first one succeeded, it will run the second one. So it's like piggybacking. So those exit codes are very, very important. Okay, cool. Okay, so this is a little complicated. On page 189, they talk about shell basics. Now, I'll confess, this is really crazy. All right, so let me just get through it, and then hopefully I'll explain what we're doing. Okay, Bash. Okay, Bash is a very big application, right? It's pretty good size because it has all this, user interface thing and history. Remember all that stuff? The CD command, all the rest of those things are built into Bash. But in scripting, I don't need hardly any of that. And so maybe we should make a cut down version of this that's just for scripting. So there's one called Dash with a D rather than B for Bash. It's D for Dash. Okay. So Bash is for user interaction, and yeah, you can use it for scripting, but it's kind of heavy. Dash, on the other hand, was never intended to be a user interface shell, prompting the user to do stuff. That was never what it was intended to do. It's used solely for scripting, so it's smaller, lighter, and a little bit faster. Okay, cool. Unfortunately, this is where things go a little crazy. So Ubuntu, in its infinite wisdom, decided that whenever you tell, for example, on line 1, in my example here, whenever you tell the machine that this is a born shell script, it's immediately going to translate that behind the scenes to Dash. Okay, so in other words, you don't ever specify Dash. You just go ahead and say, I'm going to use the born shell, and the machine goes, no, you're not. And it just changes it for you. I know this is crazy, and not all languages do that. I'm sorry, not all distros do that. So it's kind of sort of important to continue doing it the right way on line 1, which we haven't even talked about yet. But on line 1, we're going to tell it which script we're using, and we're always going to do binsh every single time. And in Ubuntu, it's going to magically do something slightly different. And if we were to run this script on someplace else, it's going to do something slightly different than that. But just bear with me. Okay. So obviously there's an awful lot of choices here for, what those things are going. Let me just tell you another crazy thing. This is kind of weird, but let me get back to my real honest-to-God guy here. Hang on a second. Okay, here we go. So, you know how when we did the command line editing, right? We did the up arrow, right? And we did some stuff, that kind of thing, right? Okay. Well, you know how you could edit the command line. If it was a really, really long command line, you could go and do stuff. There is a way that you can tell which editor to use on the command line. Isn't that cool? So when I'm typing a command on the command line, by the way, I've changed subject. We're not talking about scripting now, okay? Talking about the command line. So I'm at the command line now, and I want to edit something. I could tell it that I want to use VI as my editor, And so when I use the up arrow to get to a command, then I could say CW for change word, right? And D something, D word for D word, and XP for transpose, right? All those things. Now, I'm not suggesting you guys do that, mainly because you're probably not all that proficient in VI. But if you were, that'd be kind of cool. You can set an editor environmental variable. You could set it, one of our popular ones called Emacs back in the day. I guess you could do one for Nano, but Nano is a little more designed for graphical user interface. Anyway, yes. And so I can do set minus O VI. Oh. Okay, never mind. And then that would have set my, it's because I typed a 0. Anyway, that would have set my editor preference for the command line. Kind of cool. All right, moving on. Okay, so now we're going to talk about different types of commands that are typically used inside shell scripts. So the reason why these guys are here and not someplace else is because typically they're not used on their own. They're used inside a shell script. Okay, cool. And the first one is called the cut command. So if I just said man cut, okay. So remove sections from each line in a file. I don't. Remove sounds kind of weird. What we're doing is we're parsing. That's a good programming term. We're parsing a file and pulling out things. So you guys have heard, for example, a comma separated value, a CSV file. That's like one of the file formats that Excel uses. And you have seen before, for example, if I say cat etc. password, right? This is instead of being separated by commas, it's being separated by the delimiter is the colon. So let's say, for example, I wanted to pick. If you remember how this works, the first one is the name, the second one is used to be the password, and the ID and the group, and then the fifth one would be the name, and then next one would be what shell they're using. So if I just want to find out what shell they're using, okay, I want to strip out every single one of those guys. So I only want to get the ones I want. Okay, so here's what we're going to do. We're going to type cut. Okay, so minus D for delimiter. So now I'm telling it what the delimiter is. A delimiter could be a comma, it could be a tab, whatever. But D, in this case, the delimiter is. So let's pick, I don't know, let's pick the third one, okay? So F, the field, 3. And then I want to say, etc. password. So that's going to pull out the third one. Okay, cool. Well, let's try the fifth one. Okay, that's pretty cool. That's the comment thing. All right, so what do you think? Let's do number 7. And 7 is a list of all of the shells, okay? Now, immediately, some of these are not real, but beside the point, right? The list of shells. Hey, how would I get a unique list of shells? Okay, it would take a couple of commands to do this. I would take the cut command to pull out the 7th field, and then I would have to pipe it through sort, and then pipe it through unique. You guys remember that? Okay, and so that's it. We only got 4 choices: bash, false, sync, and no login. Cool. Okay, so that's a really cool way of parsing a text file. I have a text file that's separated by something, in this case, colon, and I want to pick the 3rd field or the 5th field or the 7th field. Cut command is what does that for you. Okay, we're coming up on the 15-minute mark. You know what's going to happen.